Welcome to Mrs. Deller's notes for her double block algebra class. These are the notes for section 12.5 entitled Completing the Square. And today we're going to create perfect square trinomials. And then we'll have a quadratic equation that we can actually solve by completing the square. Now, what we've talked about so far for how we can solve a quadratic equation, we can solve it by using the quadratic formula. That's our last resort. So I'll put it at the bottom of our list here. We could also solve it by graphing, which we saw in Chapter 9. This is kind of a review of all the Chapter 9 information. When we solved by graphing, this is where when we graph our quadratic, we got a parabola, and then we would see where the parabola crossed the x-axis. We have also factored, and that we saw in Chapter 10. And then we've also seen it where we have really simple quadratic equations where we just basically solve for x by taking the square root of x squared. So that's a little bit like what we saw in the very last section of notes, but also again in Chapter 9 where we had real simple equations where it was just like x squared equals 144. And then you take the square root of both sides and you get 12. Okay, so we've had really simple ones where we can just solve algebraically. We've graphed, we've done the quadratic formula, and we've factored. So this is all information from Chapter 9 and Chapter 10. And now today we're going to talk about one other method called completing the square. And when we have our equation in the form ax squared plus bx plus c equals 0, when we have it in that standard form, we can remove the c term to the other side, and then we'll take the ax squared and the bx and we'll make it a perfect square trinomial. Just like it said up at the top here, for our objectives that we would create a perfect square trinomial. So that's what we're going to do. We're going to make this into our perfect square trinomial. And we want to do that because when we have a perfect square trinomial and we factor them, we get the stuff in the parentheses to match, like x plus 5 and x plus 5. And then we rewrite that as x plus 5 squared. And then it'll be equal to something like 100. And then when we take the square root of both sides to get rid of that squared, then that x plus 5 pops out. And the square root of 100 will be 10. And then we can continue solving from there. Now there's a few more details that we have to worry about. So let's go through our actual steps here for what we're going to do for completing the square. So the first thing is we move our c term to the right-hand side of the equation. And again, that's when we have our ax squared plus bx plus c equals 0. When we have our standard form for our quadratic. So we're going to move that c term over to the right-hand side. Then we're going to divide both sides of the equation by a if we have a number. Sometimes that number is just 1 for a, but if it's a different number for our lead coefficient, then we do have to divide by that number. Then, to make our perfect square trinomial, we're going to take half of b and square it. That's really the process that makes that binomial of the x squared and the x into a perfect square trinomial. So this is how we make our perfect square trinomial. And then that number that we're going to get when we divide half of b and square it, we add that number to both sides of the equation because we want to keep it balanced. And then we'll be able to factor the left-hand side. And then when we factor the left-hand side, remember we'll get x plus something squared. So that's the form that we're going to get every single time. Or it could be x minus something squared. But we're always going to be able to write it as something squared because the two sets of parentheses when we factor will match. And then that allows us to take the square root of both sides and then continue solving for x. So it sounds like a lot of steps and it sounds really complicated, but once we go through our examples, you'll see that it's not that complicated. Now the first couple examples that we have here, this is just to get us practicing that perfect square trinomial concept. So right now we have a binomial and they want us to find the term that should be added to the expression or the binomial to create a perfect square trinomial. So how we want to do this is we want to figure out what term, what number we want to add on at the end so that when we factor this, we can have the same thing in the parentheses. And the way that we do that is we take half of the b term here. We take half of 10, which is 5, and then we square it. So 25 is going to be that value that we add on at the end. Now, if this was our trinomial that we needed to factor, we would think, what are the factors of 5 that add up, or 25 that add up to 10? And that would be 5 and 5. And we'd want them both to be positive. That way they add to 10, but they multiply to 25. And then we can rewrite this as x plus 5 squared. So once we take half of 10 and square it, that's the number that gets added on at the end. That's the number that makes it a perfect square trinomial. And then this is how we will factor it. So this part here is just how we'll factor it later on. This part here, this is really the work that you need to do to come up with that term that makes it a perfect square trinomial. Okay, so again for part B, I have x squared minus 18x, and then I want to add something so that way it becomes a perfect square trinomial. So again, I'm going to look at that middle term, the term that's in front of the x. And here it's a negative 18, but it doesn't really matter if we use the positive value or the negative value. So if you're one of those students who always forgets about the signs, it's okay here because we're going to take half of the number and then we're going to square it. And if you square a positive number, it becomes positive. If you square a negative number, it becomes positive. So it doesn't really matter if you take half of negative 18 or you take half of positive 18, because when we square it, that negative sign is going to go away. But really, we want to take negative 18 and divide it by 2. So that way we get negative 9. And then we'll take negative 9 and square it. So negative 9 times negative 9 is 81. So that is the value that we want to add on at the end of our binomial to make it a perfect square trinomial. So then when we factor this, I'll do it in red here. If we took this trinomial and factored it, we would want the factors of 81 that add up to negative 18. So we'd need x and then 9 and 9. And for 9 and 9 to get to negative 18, we need them both to be negative. And then we can write x minus 9 squared. So that's why we want that number to be 81, so that way we can do this type of factoring, because it's really easy to do. Okay, so the next thing that we're going to do then is we're going to actually do some completing the square. So we've got 4 examples, and then we have a word problem. So these first couple examples here, A and B, we could solve these with other methods. These are easy equations, easy quadratics. Now we can't just solve this one by taking the square root or anything like that because we do have that x term. So we could factor this. We could, I'll do it off to the side, we could find the factors of 3 that add up to 2. So when we factor this, we could write it as x and x, and the factors of 3 are going to be 3 and 1, and to get them to add to negative 2, we need the 3 to be negative and the 1 to be positive. And then we could set each of those equal to 0 and solve, so we'd get x equals negative 1 and x equals 3. So if I had a choice, that's the way I would solve this problem if it just said to solve. That's the way I would do it because this is factorable. But we're going to start off with a couple easy problems here where we're just learning that completing the square process. So these examples are easy, but as we get into the other examples, I'll show you that we have to use completing the square to solve those. Okay, so our first step is to get rid of this c term. We've got all our terms in descending order here, so I'm going to move that c term over to the other side. So we'll have x squared minus 2x, and I'm going to leave a little space there on purpose because I am eventually going to fill this back in with a perfect square trinomial, okay, or with a number that makes it a perfect square trinomial, okay? So now I have to do that process to get my perfect square trinomial. So I have to take half of -2, which is -1, and then I have to square it, which gives me +1. So that's the number that I'm going to put in here to make this a perfect square trinomial. And then what I do to one side, I have to do to the other. So I haven't really done much to this problem yet. I've moved a term over, and then I've added the same amount to each side. So I've just made equivalent equations. That's what this whole process is called. Okay, but now I have a trinomial here that's going to be a perfect square trinomial. So now I want the factors of 1 that'll get me to -2. And the factors of 1 are 1 and 1, and the way that I add them to be -2 is to make them both negative. And then 3 plus 1 is 4. Now, since the stuff in my parentheses is exactly the same, I can write it as x minus 1 squared, and then I have it still equal to 4. So now to finish solving, I'm going to take the square root of both sides, so that way the squared will cancel, and then I'll have that radicand that pops out. So we've seen that in the previous lesson as well, where you have multiple terms in your radicand. Now here, when I take the square root of 4, technically I get plus and minus 2 as an answer. So that means I have to make two little equations. I need x minus 1 equals +2 and x minus 1 equals -2 so that I can solve each of them. And I should get these answers up here. So when I add the 1 over, I get 3. Hey, that's the same as what I had up here. And when I add the 1 over, again, same work, but different answer. I'm going to get -1. And that's the same answer that I had up there. So these are my two answers that I get from the process of completing the square. But if I had a choice, I would have done the factoring and setting both parentheses equal to 0 and solving, because that's much easier and much faster. The completing the square does have a lot of work to it. But again, we want to start with some of these easy examples just so you understand the process. Okay, now for part B, this is another one where if I had a choice for how to solve this, I would subtract the 12 over, and then I would factor with guess and check, because the factors of 12 that'll get me to 2 are going to, or to 4, are going to be 6 and 2, and I need the 6 to be positive and the 2 to be negative, and then I would set each of those equal to 0 and solve. So I would get x equals -6 and x equals 2. So there my work's done in about 3 steps. So if I had a choice, that's what I would do, and that's what we've done in previous sections in the homework. But today they want you to solve with the completing the square. So let's take a look here. I have my x squared term and then my b term, or my x term, and then here the c has already been moved over to the other side. Originally in part A it was all set equal to 0, so then I added the 3 over, but here that 12 has already been added over. So that's good, that saves me a step. But now I have to take half of 4, which is 2, and then I have to square it. So I get 4 back again. Now that's just a coincidence. That's not some secret math trick that I'm not telling you, okay? When you take half of 4, it's 2, and then 2 squared gets you 4 again. And that's just how the numbers work. So x squared plus 4x equals 12. I'm going to leave that little space there because that's where I'm going to add in my 4 that makes it a perfect square trinomial. And if I add a 4 to the left side, I have to add a 4 to the right side of the equation. So now I'm going to factor, and remember this stuff, when I factor it, I'm going to get the exact same thing inside the parentheses. It's not going to be different factors like this method was. It's going to be the exact same numbers. So the factors of 4 that'll add up to 4 are 2 and 2, and I need them both to be positive. So now I can rewrite that as x plus 2 squared equals 16. And then when I take the square root of both sides, I'll get that squared to cancel. So the radicand pops out, and then I get plus or minus 4. Now here again is where I need to set up my two equations. I need the x plus 2 to be equal to a positive 4, and the x plus 2 to be equal to a negative 4. So take the time to write out both of those, so that way you don't forget or you don't accidentally get the wrong value. So here, when I solve, I get x equals 2, which is the same as what I had over there. And then here I subtract the 2, and I get x equals negative 6. So again, that's the same as what I had over there. Now you don't have to do both methods. I'm just showing you how this method here in purple, where when we set it equal to 0 and we just factored with guess and check and then set the parentheses equal to 0, that's a way to do this problem, and it'll get you the same answers as if we complete the square. You don't have to do both sets of work for the homework. Okay? You just have to do the completing the square process. I'm just trying to make a connection between previous work and new work so that you can see that, yes, you get the same solutions. Now, these next two examples, though, you can't do by doing guess and check. And the reason is that here it's all set equal to 0 again. My quadratic is all set equal to 0. I've got my x squared and then my x term and then my number. So they're in descending order. It's all set equal to 0. Excuse me, to 0. But if I tried to solve this with guess and check, I would need the factors of 2 that add up to 14. And there aren't any factors of 2 that'll add up to 14. So no factors of 2 will get you to 14 or equal 14. Okay? Because the factors of 2 are 1 and 2, and you can't add up 1 and 2 in any combination to get 14. So if I had a choice for how I could solve this, I would have to do completing the square. So to start my completing the square process, I'm going to move that c term over to the other side. So now I have x squared plus 14x equals 2. Now I'm going to leave a little space here because that's where I'm going to get that third number that's going to make the left-hand side a perfect square trinomial. So I'm going to do half of 14. It's always this middle term here. So 14 divided by 2 is 7, and then I square the 7 and I get 49. So that's the number that's going to make my binomial into a perfect square trinomial. And what I add to one side, I have to add to the other. So now I can factor this, x squared plus 14x plus 49. I can factor that into x and 7 and 7. The factors of 49 that add up to 14 are going to be 7 and 7. It's going to be the square root of 49. It's always half of this middle number, like we got over here, this number right here. And I want them both to be positive because they're adding up to a positive 14. And then it equals 51 this time. So then I'm going to write x plus 7 squared, since the stuff in the parentheses is exactly the same. And then I'll take the square root of both sides so I can get rid of that squared. Now I write it as squared and then I undo the squared. And that's so that I have just one simple solution here. X plus 7 equals, now I can't take the square root of 51. So I'm just going to leave it plus or minus square root of 51. And 51 is not a perfect square, and I can't break it down either. But I still have to solve for x. So how I do that is I subtract 7. So x equals, Now here's the trick. It's kind of like a little shorthand trick. I can't combine 7 and the square root of 51. They're not like terms. So I'm just going to write negative 7 plus or minus the square root of 51. I write the whole number first, and then plus or minus the radical. And that's my answer. Now, if I actually separated these out and got two answers, I'd have to do negative 7 plus the square root of 51, and then negative 7 minus the square root of 51. And 51, the square root of that is a decimal. So if I did 7 plus that decimal or negative 7 minus that decimal, I would get another decimal for an answer. And that's not as accurate as leaving it as a radical. So I'm going to leave my answer as a radical. All right, one more like that in part B. And here again, if I had a choice for how I wanted to factor this, I wouldn't want to do guess and check. And we'll see why in just a moment. Okay? Now here I have my x squared term and then my x term, and that c term has already been moved over to the other side of the equation. So that's a good thing. But when I'm completing the square, I can't have a number in front of the x squared. So my first step here needs to be dividing every single term by 3. So then I have x squared minus 24x, and I'm going to leave a little space because eventually I'm going to add in a number to make it a perfect square trinomial. And 18 divided by 3 is 6. So really, if I was given this trinomial, it would be x squared minus 24x minus 6 equals 0. There aren't any factors of 6 that'll add up to 24. So again, I'm going to write no factors of 6 will get me to 24. So I could have 6 and 1, 2 and 3, but I can't add or subtract those in any way to get me to 24. So I can't solve this with just general guess and check and setting the parentheses equal to 0. I could solve it with the quadratic formula. I could subtract the 18 over and then have my values for a and b and c and substitute them in, but that's going to be big numbers. I've got 72 and 18, so that might get me a lot of large numbers to work with. I could still work through it, but this method is going to be a little bit nicer because it's going to let me do perfect factoring. Okay, so now I have to take half of this middle term, the 24. So 24 divided by 2 is 12, and then I have to square it. 12 squared is 144. So that 144 is the number that I'm going to add in so that I get a perfect square trinomial. So now I want the factors of 144 that'll get me to 24. So I need an x and an x, and the square root of 144 is 12. Half of 24 is 12. It's the same number over here, same number there. So I'm going to use the 12 and the 12. Now this, this time I want the 12s to be negative, so that way they, excuse me, add to a negative 24 and multiply to a positive 144. And then it's all equal to 150, the 144 plus 6. So now, since the stuff in the parentheses matches, again, that should happen every time with this perfect square trinomial factoring. So if you don't get the stuff in the parentheses to match, then you're doing something wrong. So they should match, so that way I can write it as x minus 12 squared. And then I undo the squared, so that way I just have one x that I'm solving for. So I have 1x minus 12 equals the square root of 150. So far it's been very similar to what we did in example A, just more practice. But here, the square root of 150, it's not a perfect square, but I can break it down. There is a perfect square that goes into 150, and that's 25. And it goes in there 6 times. So really, this is x minus 12 equals, oh, I forgot my little plus minus. It equals plus or minus 5 times the square root of 6. The square root of 25 is 5, and then the square root of 6 is my leftovers. So I can't write this out as a decimal because that wouldn't be as accurate, so I'm going to leave it as plus or minus 5 square root 6. And I still have to solve for x. So to do that, I have to add the 12 over. Now, I can't combine these numbers. I know I have a 12 and a 5 here, but this isn't just 5. This is 5 times the square root of 6. So these aren't like terms. So when I write my answer, again, I'm going to write it all as one big term. 12 plus or minus 5 square root 6. And then that'll be my answer. Now, again, that's the same answer that you would get if you did the quadratic formula. Okay, so if you have questions about that in class, or you want me to show that to you in class, I can show you how if we took our value for A is 3, and our value for B is negative 72, and our value for C would be a negative 18, substituted them into the quadratic formula. This is what you would end up with. So all of these methods for solving quadratics, they're all connected. And this completing the square process is just another method, oops, oops, that lets us work through problems that are a little bit more challenging. So for example 4 here, we have a word problem. So you're probably going to see some word problems in your homework as well. And here we have Computech, and it's a small company that makes and sells computer parts. Okay. The company models its weekly profits, P, using this equation. So here's our quadratic, and X is the number of computer parts sold. So if they take those number of parts and square them, I multiply it by 2, and then take the number of parts, multiply it by 36, and add those two numbers together, and then subtract 206, they'll get their profits. So they want to know how many computer parts they have to sell in order to make a weekly profit of 5,000. So they want to know how many parts. So the computer parts, that's X. X is the number of computer parts. So we're going to be solving for X. And then they tell us that the weekly profits are 5,000. And that's what P is. P is our weekly profits. So my first step then is going to be to substitute in the 5,000 for the P, and then rewrite the rest of the quadratic. Now usually the quadratics that we've been working with, they have it so that it's all set equal to 0, and they have all the x squared terms on the other side. So I'm just going to take a moment here and I'm just going to flip-flop this around. This is the, whoops, reflexive property here where you can flip-flop things around on the equals, on each side of the equal sign. So it's the exact same equation. Instead of just having equals 0 over here, I just moved it so it was equals 5,000. So now it's like the problems that we saw in example 3, where I'm going to move that C term over to the other side. So then I have 2x squared plus 36x, I'm going to leave a space, equals 5,206. And when I want to do my perfect square trinomial, I can't have a lead coefficient, so I have to divide everything by 2 first. So now I have x squared plus 18x equals 2,603. So now I can do half of this middle term here. Half of 18 is 9, and then 9 squared is going to be 81. So that's the number that I'm going to add in to make a perfect square trinomial, and then I'll add that over to the other side as well. So now I can factor. So the factors of 81 that'll add up to 18 are going to be 9 and 9, and I need them both to be positive. And again, that's the same as this 9 and this 9 right there. And then 2,603 plus 81, that's 2,684. So now, since the stuff in my parentheses matches, I'll write it as x plus 9 squared equals 2,684. And then I'm going to take the square root of both sides. So now my x plus 9 pops out because the square root and the squared cancel. Now, when I'm dealing with this number here, this 2,684, it's not a perfect square, but since we're dealing with realistic terms here, well, realistic in terms of math word problems, we're trying to find out how many parts. And when we talk about computer parts, we don't say, oh, I have the square root of 2,000 parts. We want to actually make this a decimal, okay? So when we take the square root of that, we'll make a decimal and we'll round it to two places here. So that's 51.81. So that makes a little more sense that we've got 51 parts. Now I'm rounding just for now. As we get to our final answer, we'll determine if we need whole numbers or decimals for our final answer. And when I'm dealing with this plus or minus here, again, remember, I would have two equations. X plus 9 equals positive 51.81, and then x plus 9 equals negative 51.81. Now this equation makes sense. This means I have 51 parts, and I can subtract 9 from that, and I'll get x equals 42.81. So we could round and we could say we need 42 parts if you wanted to be very literal in your interpretation, because you can't have 0.81 of a part. So you could say you need 42 parts, or we could round and we could say we need about 43 parts. So that way they actually make their whole $5,000 in their profits. So if they actually want to make that profit, they need this 0.81 of the part. So like literal students think you can't have 0.81 of a part, you need a whole part. Well, you're right, they need to go up to that next whole part. So that way they can make all of their $5,000. Now this other problem here, I've got a negative. I've got a negative 51.81. That doesn't make any sense. That means I have negative 51 parts. That means I can make 51 of them that are wrong. I can throw away 51 of them. That doesn't make any sense. And if I subtracted the 9, I'd get a bigger negative number. So this doesn't make any sense for our word problem. Okay, it doesn't make sense to have a negative number of parts. So our final answer then is going to be 43 parts. And again, if we wanted to write that as a whole sentence, we would say that Computech needs to sell 43 parts in order to make $5,000 in profit. That's what is happening here for this problem. So again, we can solve this problem by completing the square, or we could also solve it using the quadratic formula. But again, it would be large numbers to put into the quadratic formula. But here we're getting decimals anyway, so that might be okay to work through that formula problem with the quadratic formula. So if you want to see that in class, we can do that in class. I can show you how the quadratic formula will get you the same answer. So definitely have your notes with you when you're working through these practice problems. There's a lot of steps, and sometimes if you mess up one early on, then it throws off the rest of your work and your answer for the rest of the problem. So if you're getting stuck, come on in and see me before school so that way I can help you out.